What is a unit vector perpendicular to the plane defined by the vectors A and B? Alright. Alright. We got a problem on our hands. How are we going to solve it? You're going to find out today. So, the first thing you can know is that a plane, all a plane needs is two vectors to really be able to define it and to know some information about it, right? Like if you look at the xy plane, the xy plane is defined by two vectors, and those vectors are x and y. And you could define them by like 0i plus 1j and 1i plus 0j. You know what I mean? And we want another vector perpendicular to this plane. So how could we do that? Well, it's actually pretty simple. These two vectors lie on the plane, right? That they're on. They're on that plane. So if you want to find something perpendicular to them, you're looking for a vector that kind of sticks out, maybe like in this sort of it's kind of hard to draw, but imagine this is like shooting out. So what that means is A cross this B is going to get you a perpendicular vector. So all you have to do is take a cross product of these two. So let's go to blue. So this will be vector C. So some vector C is A cross B. And this vector C will be perpendicular to the plane of AB. Okay? So how do we cross product? Well, first we can set up a grid of our i's and j's and k's. So I hat, j hat, k hat. And then what you want to do, this is just how I do it. There's a ton of ways to do cross products. So you take the coefficients of each vector. I'm going to put a 0k there. So the coefficient of the first one is 2, and for this A, this is 4, and that's 0. Okay? Excuse me, fuck. You're going to do the same thing with B. That's a 1 in front of that I, that's a 1 in front of that J, negative 1 in front of the K. So how I do cross products, let's say I'm looking for the I component, I would eliminate this column, and then I do the determinant of 4 and 0. So eliminate that column, do 4 times negative 1, actually I'll do it in red, 4 times negative 1 plus 1 times 0, or minus 1 times 0. I hat. Then this one is going to be minus. You always do a minus for j. This is just how I do it. Eliminate the j. And then you do the determinant here. 2 times negative 1 minus 1 times 0. So 2 negative 1 minus 1 0 j hat. And then k hat, I'm going to do, you do addition again. And you eliminate this column. Determinant here. So 2, 1 minus 4, 1 k hat. So solving, you get negative 4, and that's just a 0. I'll go to 0. So negative 4 I hat. And then you have minus negative. This is a negative 2. So you have positive 2 because these and these. And then you have 2 minus 4. That'll give you negative 2k hat. Okay. So now you have the vector C. Is that what we want though? Let's see. No, we want the unit vector. So what is a unit vector? A unit vector is just the vector over its magnitude. Okay? So all you have to do now gotta find the magnitude of C, take all your components, square them, square root them. So supposed to be negative 4 squared. 2 squared. Negative 2 squared. That's going to equal 16 plus 4 plus 4. That's going to equal root 24. We can break that into root 4, root, not 3, 12? No, 6, sorry. And that's going to be equal to 2 roots of 6. Okay, so now we know magnitude C is 2 roots of 6. So now to find the full unit vector, take the vector over its magnitude. So that's going to be 1 over 2, 6 multiplied by negative 4I plus 2j minus 2k. The only thing I see left that we can do is we can eliminate these 2's, because you see how every component has a 2. That'll be a 2, that'll be a 1, that'll be a 1. So now we have C over magnitude C, the unit vector, 1 over root 6, 2I hat plus j hat minus k hat. Just be careful with your negatives on this on these problems, especially when you get up to like when you're doing the cross product. Don't forget that negative j. And if, you know, some other people they'll do a problem and they'll put the j over here. That's fine too. I'm not going to explain that. Yeah, that's about everything.